This is a video on Introduction to Algebra. It's Vedic math way. We will use some sutras here. Video is video number A1. This is a new series sequence A1. Introduction to Algebra, Vedic math way, video number A1. Here are some sutras I worked out for the algebra, and they apply to monomials. Monomials are part of polynomials with only one term. Okay, let's continue here. Add. If you're trying to add two monomials, if the flags are same, that means powers are same, we add the numbers, and number mean we add the coefficients of the two terms. Let's continue. In subtraction, in two monomials separated by minus sign, if the flags are same, that means same power, subtract the numbers, which is would subtract the coefficients. Same thing in multiply. If flags, add the flags and multiply numbers. Number mean multiply the coefficients. So we add the two flags, two powers, values, and multiply the two coefficients. In division, divide with we subtract the flags, subtract powers, and divide the numbers. So we subtract the flag of the divisor from that of the dividend. We divide the coefficient of the dividend by that. Okay, outline here, algebra basics. This section we are going to discuss is basics and background of algebra. Then we have one section on add, subtract, another one for multiply, another one for divide. This section covers the basics and background, and which students should be familiar with the background. At least the students should know what the algebra is for, how does it compare against the number math, and what does the flag means, and what does the number mean, and also it should know what the classifications are. If a polynomial, is it a monomial, binomial, trinomials, or another polynomials, and also degree of the polynomial. So these basic things students should be familiar with. What's algebra here? Algebra is a variable math. In algebra, we use variable, usually x, y, or z, instead of numbers. Okay. Unlike number math, algebra needs support of the numbers. We use the numbers for coefficients and also which are constant multipliers, and also for the power of the variables. Let's continue. An example, in 3x, which is 3 times x, where 3 is a coefficient. In books, it's stated as 3x, which is illegal syntax for programming language. We would be using 3 times x. The star thing is multiply. In books, they would use x for multiply, and I also have variable x, and it will be confusing. So 3 star x is 3 multiplied by x. Let's continue. And in example 3 times x squared, 3 is a coefficient and 2 is a power. 2 is a power. What does it do for us? Okay? Algebra allows us to express numeric thoughts even when we do not know the values of the involved numbers. So algebra allows us to express numeric thoughts even when we do not know value of the involved numbers. Let's continue here what I mean. If the problem states that 3 times square of a number plus 5 times number plus 7 is 29, we can use a variable x for the number. Okay, and that tells me 3 times square of number, 3 times square of x plus 5 times number, 5 times x. X we are using for the number we don't know a value of, plus 7 is 29. Okay, and the answer for that thing is x is 2 is one of the answers. Let's continue here. Instead of repeating a large expression, we might say that expression is e, and from now on we would say use e instead of the number. So if the large expression someplace, then we might say, hey, its expression is e, and we would use that instead of the large expression. Okay, that gives me a shorthand notation. We would use we would be using algebra expression notation E. Values of variables. Okay, the variables may assume one value. Individuality we would call, and that's what the Glover called individuality. We might get multiple values, which is multiplicity, and we might get a value from a universe, which is universality. Universality and individuality are terms used by James T. Glover. Let's continue here. Individuality, a variable can have a single value. When we assign that value, say e.g. Like example is x equal 10. So x, we have assigned a value x 10, so x has from now on in this current context, x has a one value, which is 10. A solution of equation can give you one value, which is 5 times x minus 3 would give you x is 3. Okay? A linear equation would get you one value of multiplicity. A variable can have multiple values. Let's continue here. We might assign multiple values in considering colors favorite to a group of fox. We might say let x be set of those colors, or we might say a variable y represent all the weekdays. That means it would get you represent Monday, Tuesday, Wednesday, Thursday, and Friday. Okay, so we can assign multiple values. Okay, that will to a variable, that's multiplicity. We might solve an equation to get multiple solutions, like 15 times x squared plus x minus 6 is 0, has two solutions. One is x is equal to minus 2 divided by 3, or 3 divided by 5. Universality. A variable may be used to express a general value and have universal applicability. Example, a point x on x-axis can have infinite of real values between minus infinity and plus infinity. So a point x on x-axis, which is given by y equals 0, may have infinite number of values, which is real values though, between minus infinity and plus infinity is still a point on the x-axis. Let's continue. A solution of a magnitude of x is 1, has two solutions, plus 1 and minus 1, when x is real. However, for complex x, its solutions are all the points on unit circle around the origin and is in a complex plane. Let's continue here. Another example, x plus y squared, square of x plus y is x squared plus y squared plus 2 times x times y applies to whole universe of values for x and y. Let's try to compare that with the number math. Okay. In decimal number system, a number is given by a linear combination of powers of 10. This is power of 10. This is my linear combination coefficients of ith power of 10. Okay, let's continue. An algebraic expression E in x is given by a linear combination of power of x. Okay. So a number and expression are similar, except that in decimal number system we use 10 powers of 10 for linear combinations, and in a expression E we will use a powers of x. Okay, let's continue here. Expressions are similar to numbers. If you compare these, this is a linear combination of power of 10, and this is a linear combination of power of x. They're similar. Their linear combination of power of 10 numbers are, expressions are linear combinations of power of x. X in algebraic expression is similar to 10. If you compare these two number and expression, and if x were 10, then 2 would be equivalent. Okay, so in X in algebraic expression is similar to 10 in a decimal number system. Let's continue here. So that would mean rules developed for number math apply to algebraic expressions too. So we can use the same rules we developed for number math. Classification. Let's try to see how can we classify a algebraic expression. Continue here. We can do by number of terms in the expression or by largest power of x in an expression. Let's continue here. By number of terms, you can look up this site here and for reference. So that tells you. Okay. So monomials are their one term. Example is 3 times x power flag 1 or power 1. 7, which is 7 times 0th power of x, or 6 times 5th power of x. These are single terms. A coefficient, which is number, variable, and a flag. Number multiplied by variable and a flag, that is a one number, one variable, one flag. That is a monomial. So this is a 7 here is a number, and 0 is a flag, and x is a variable here. So this is a one monomial. This is also a monomial. Let's continue here. Binomials is for two terms, which consist of two monomials, like a times x plus b. This is a is a coefficient, x is a variable, and its flag value is 1. Here b is a coefficient, x is a variable whose flag value is 0. Let's continue here. Trinomials are for three terms, like a times x cubed plus b times x5 plus c times x second power. Let's continue here. These are all special cases of polynomials. Okay? If you look at this site here, it tells that polynomials have only positive powers of x of variable, not negative powers, including positive powers, including the power 0. Okay? So flag value in a polynomial can be either 0 or 1 or 2 or we can do for by largest power of terms. So if in this expression a x cubed had a power 3, flag value is 3 here, and next but monomials in here is b times x5, so its flag value of second term is 5, and that of the third term is 2. Let's continue. Power of terms are 3, 5, and 2. 5 is the largest term power. Largest power is 5. Largest flag value is 5. That tells me degree of polynomial is 5. Of this polynomial, which is a times x cubed plus b times x to the 5th power plus c times x squared, its degree of this polynomial is 5. Let's continue here. Example, e is 5, a constant term, if it's, and that's like 5 times x0, and its degree is 0. If expression was 3 times x or 2 times x plus 7, these are linear terms, okay, and these have a degree of 1. In 3x squared or 2x squared plus 3x or 5x squared plus 7 times x plus 2, highest power is 2 here, highest flag value is 2 here, highest flag value is 2 again, and they are 2, and they are, its degree is 2, and they are quadratic expressions. Okay, this is a constant, this is linear. When flag degree is 1, it's a linear term. When degree is 2, it's a new. Let's do exercise here. Identify if the following are monomial, binomials, trinomials, or none of the above. Are these some other type of polynomials? Let's continue here. So is that a monomial? Is that a monomial? So what is that one? Is the monomial, monomials, or trinomials? Okay, let's continue here and some more examples here. Another example exercise here. Now we have to identify if they are constant term, linear, quadratic, cubic, or polynomials of higher degree. What is the degree in question? Let's continue here. Example -8. Example, next exercise is x minus 4. Next, x squared minus 4x plus 6, and so on. Let's do some definitions here. Like term, this is the term used by Glover. These are terms where power of the variable is same. We'll call same flag value. Like terms is from James T. Glover's books. Okay, let's continue here. That's an expression a times x squared plus b times x to the power 5 plus c times x cubed plus d times x squared. Okay, there are only two terms that have like terms. These are a times x squared and d times x squared. Its flag value is 2. Its flag value is 2. This is 5 and 3. The 2 and 2 match. These are the like terms. A times x squared and d times x squared are like. Or a times x squared is like the term d times x squared. Let's continue. Okay, sutras used. Let's see what we are going to do with sutras in question here. Continue. Sutra. There is sub-sutra which is translated to on the flag. In the original Sanskrit version, it uses two nouns, flag and a number. Let's continue here. In using same sutra to compute differential, Tirthaji adds a verb reduce and interprets it as multiply flag by the number which is coefficient and reduce the power by 1. Okay, reduce the flag value by 1. Okay, and we will use similar liberties to make up a sutras here. Okay, we will use same. We will just play with this two nouns here, flag and a number, and make up sutras to use in addition, subtraction, multiplication, and divisions of monomials in algebra. Let's continue. Let's continue. Now we are on add and subtract section here. Okay. Sutras for add and subtract are, let's see what happen. Flag power is same. Flag or power is same. We can add the numbers which are coefficients. Okay. If the two monomials are joined by either plus or minus, we can, and they have same flag value, we can compute, add the coefficients or subtract the coefficients. Let's continue here. In addition, two monomials add coefficients when flags match. Okay? In subtracting monomials, subtract coefficients when flags match. Let's continue here. Example, 3 times x to the power 5 plus 7 times x cubed. The two flag values are 5 here and 3 here. And they are not the same. They do not match. So no further simplifications possible. So it still says 3 times x to the power 5 plus 7 times x cubed. Let's continue here. Good news, bad news. Good news is there is no carry and no borrow. Bad news is there are negative numbers. But in manipulating these numbers, first of all, various monomials might have a negative values. The coefficient might negative, or we might end up getting a negative coefficients after some manipulations. We will use the same flag in discussion here instead of like terms. So if two monomials are like terms if they had the same flag value. So we would use, if two terms are two monomials have same flag, we can do add and subtract. Let's continue here. In the above, 3 times x to the power 5 plus 7 times x cubed. Okay, it's like 3 apples and 2 oranges, and they just say 3 apples plus 2 oranges. No further simplification is possible. This is a x to the power 5 term, and this is x cubed term. So they are two different kind of terms, and they don't have same flag value do not match, and they are like apples and oranges. Let's continue here. However, if there's 6 oranges and 5 oranges, then we can make it, add them up to make it 11 oranges. Let's continue. Let's do some example here. It's a subtraction example now. 4 times x minus 3 times x is a 4x and minus 3x. They are same power. Flag value is 1 here. Flag value is 1 here. And so we can subtract 4 minus 3. We subtract the coefficients. Let's continue here. Do have same flag values? Do they have them? And yes, if you don't see that, rewrite the thing. Okay. So if you say first power of x and first power of x here, so now they have same flag value, and now we can subtract. How about now? Okay, let's continue and apply the sutra. Flag same, subtract the coefficients. So e is expression e, 4 times x minus 3x is 4 minus 3 times x, okay, which is subtract the coefficients. Okay, so 4 minus 3 is 1, it's 1 times x. We might even say x and omit the 1 times, because 1 times the number is same number. Okay? Let's continue. Do some examples here. How about now minus 4 times x4, 4th power x, plus 2 times 4th power x. That's equal to minus 4. So we would just add, subtract the coefficients here. So x fourth, this is flag is 4, flag is 4, and we are trying to add the two monomials here. So it's minus 4 coefficients here plus 2 coefficients here. So we add the 2 together, minus 4 plus 2. And let's continue here. And are you comfortable with this situation here when you are trying to subtract a larger number? Minus 4. Let's try to subtract 4 from a 2. Okay, 2 is a smaller number. We are trying to subtract a larger number. Let's continue here. When we did this video, subtraction as a game, and that's the, in this video we had a rule to subtract smaller number from a larger number. Let's continue here. How do we handle that? So if there's an issue, let's see if we can make it converted to subtracting a smaller number from a larger number. Okay? Let's continue. So we can do this. This is the situation right now. We have minus 4 plus 2 is the coefficient times x 4th power of x. Let's continue here. How do you handle that? We apply sutra, transpose and apply to convert that to an equivalent expression. So minus 4 plus 2 is asking for subtracting a larger number from a smaller number, and we would change that to an equivalent expression by using transpose and apply, and we will end up with subtracting a smaller number from a larger number. Let's continue what we do here. We are going to do by multiplication and by dividing by minus 1. We would, this minus 4 plus 2, we would multiply by minus 1 and also divide by minus 1. Let's continue here. And look at that. If a, we are trying to divide minus 1, okay, and if you multiply and divide this a divided minus 1 again by minus 1, you see that it comes out to, in denominator we got plus 1 here, so a times minus 1. So a divided by minus 1 is equal to a times minus 1. For your information, when we multiply by minus 1 twice, we are using sutra by multiplying and dividing by minus 1. So we would do multiply and divide that by minus 1. Let's see what I mean by, okay, multiply by minus 1 here and divide inside, okay, that means minus and 4 minus 2. We just, now we are subtracting a smaller number from a larger number, so it's a minus 4 minus 2 is 2 here, and 4th power. Let's continue with add and subtract. This time we would do binomials. That means we would take expressions consisting of two terms. Let's continue here. My E1 is minus 3 times x cubed plus 8 times x fourth. So it has two monomials. One is minus 3 times x cubed, another is 8 times x power 4. Let's continue here. And E2 is 5 times x, one monomial, another one is minus 6 times x cubed. So E1 has two terms and E2 has two terms. We call them binomials. Let's continue here. So we have to find E1 plus E2. That's the problem here. Highest flag value is 4. Let's look at flag values. 3 here and 4 here. So far 4 is the highest. There's one flag value 1 here and 3 here. Is 4 is still the highest value, and lowest value is here. 5 times x has a flag value of 1. Highest value is 4 and lowest value is 1. Okay, that means let's go write down my powers here. Fourth power x, third power of x, second power of x, and first power of x. We would accumulate the corresponding flag values under this column with we would collect all the terms with value of 4, flag value of 4 under x fourth column, and all the values, all the monomials with a flag value of 3 under the x cubed column, and all the monomials with the second power x under x squared column, and all the values monomials with the flag value of 1 under x power 1 column. Let's continue here. So first thing is minus 3x cubed. This is the first monomial I run into. So it is a minus 3 times x cubed. So under x cubed, it's a minus 3 is the coefficient, and x cubed is the variable part, and 3 is a flag value. Let's continue here. Next one is plus 8 times x fourth. So coefficient is 8 is plus 8. That's what we write down here. Let's continue. Next is 5 times x. This is a coefficient, flag value is 1. So coefficient 5 would go under x1. Let's column x1. Let's continue here. So we got a plus 5 here. Next is minus 6x cubed. Flag value is 3. So it's going to come in this column here. Let's continue here. So we get minus 6 here. Now we would add the numbers in the columns. Add in each column. Okay. So what do we do here? This is 8, only one digit here. So plus 8 is the value. So result has a plus 8 times x fourth. Okay, next is minus 9 here. Minus 3, minus 6. Add them up is a minus 9. And that's minus 9x cubed. Okay, and nothing under, no term under x squared, so 0x squared, and 5 under x first power, so plus 5 times x. Let's continue here. So 5 here. That means E1 plus E2 is 8x fourth minus 9x cubed plus 5 times x. Now we will add and subtract linear terms here. Linear is a term with the highest power of x, highest flag value is 1. Okay, so this is a linear term here now. And if you look at number of terms, it's a 2, so it's binomials, but I would call linear here. Okay, linear is given is the classification by the highest flag value. So 5 times x is minus 6 is the second linear term. Let's continue here. So we do E1 minus E2 this time. Let's continue. Okay, we know how to do E1 plus E2, so we would transpose E2 into minus E2. Let's continue what I do. So E1 minus E2 is 3 times x plus 7. That one. minus that one, 5 times x minus 6. Okay, now we would transpose this e2 so that I have plus here. Continue here. So that means it's 3 times x plus 7 plus here and times minus 5 times x plus 6. I change the sign of 5 from positive to negative, and for 6 from negative. Continue. So e1 minus e2 is, that's what it is, 3 times x plus 7. We are repeating this, some of the sections from the previous slide, which is that after we transpose, and highest flag value now is 1. Look at here, we just transpose here, and what we did is we multiplied and divided by minus 1. Okay, so when you multiply this minus sign by minus 1, it becomes positive. When I divide 5 times x by minus 1, it becomes minus 5 times x. And when I divide minus 6 by minus 1, it becomes plus 6. Let's continue here. So x1, let's continue. Highest flag value is 1 here, and this one is highest flag value 1, and this is the lowest is 0. Constant term has a flag value of 0. Constant term 7 is equal to 7 times x power 0. Let's continue here. So first term is 3x times x, so we plus 3x under x, plus 3 under column x1. Next is plus 7, this is a constant, it goes under the column 0th power of x. Continue here. Next term minus 5x here, minus 5 goes under, coefficient minus 5 goes under the column with a title of first power of x. Next is plus 6 goes in next column here. Let's continue. Now we would add up in the columns, add in columns. Okay, so that 3 minus 5 is minus 2. Okay, and 7 plus 6 is 13. Okay, so that means I have a minus 2x plus 13 is the result of doing e1 minus e2. Let's continue. That means e1 minus e2 is minus 2 times x, minus 2 times first power of x is same thing as x, and 0th power of x is same thing as 1. So 13. 13 times 1 is 13. So it's e1 minus e2 is minus 2x, that one here, plus 13. Now we just did a linear expression. Now we would do a add quadratics. Quadratics means a highest power of a monomial in a expression is 2. So this 2 here, e2 is minus 2x squared plus 5x plus 15. So this is 2 is the highest power and 0 is the lowest power of x. Okay, and we're trying to add this number together, e1 plus e2, and we just write down this expression here and plus the second expression here. Let's continue here. Highest flag value is 2. This 2, 1, 0 flag value, and this is 2, 1, and a 0. Highest is 2, and lowest flag value is 0. So these are the columns I need. Second power of x, first power of x, and 0th power of x. Let's continue here. Collect terms in column. You're going to collect terms. So 3x squared, 3 goes in the column x squared. Okay. Then plus 7x is 7 goes under column first power of x. The minus 6 constant term goes under 0th power of x. Minus 6 goes in. So now a second term here, second expression, which is e2. So minus 2 for x squared, plus 5 for x, and plus 15 for constant term. Let's continue here. Okay, so now we would add up in the columns. Okay, 3 minus 2 is plus 1, 7 plus 5 is plus 12, minus 6 plus 15 is plus 9. Okay, that is 1x squared plus 12x plus 9 is the answer of e1 plus e2. Okay, let's continue here. That means e1 plus e2 is equal to second power of x plus 12 times x plus 9. Okay, let's continue. That's x squared plus 12x plus 9. Okay, let's look at some examples of subtracting two cubic expressions. Let's see what I mean by that. The first expression example is E1 is 4x cubed plus 3x squared plus 7x minus 6. Second one is E2 is minus 7x cubed plus 9x squared plus 6. We call these the cubic expressions because highest flag value is 3. Let's see. This one is E1 is a cubic expression because highest flag value is 3. E2 is cubic expression because highest flag value is 3. Let's continue. So we have to E1 minus E2, which is equal to, now we replace E1 by right hand side of E1, which is 4x cubed plus 3x squared plus 7x minus 6, and this minus sign here, and E2 minus 7x cubed plus 9x squared from here, and plus 6. Let's continue here. Highest flag value is 3 and lowest flag value is 0. This is a 3 here, and constant term has a flag value of 0. Flag value 3, flag value 2, flag value 1, and flag value is 0. Same thing here. It's a flag value 3, 2, and a 0. Let's continue here. Okay, and so we need a column for x cubed, for x squared, plus first power of x and plus 0th power of x. Let's continue here. We would collect terms in the columns. First term is 4x cubed, flag value is 3, and this is the first column here. We will collect that 4x cubed, 4 coefficient 4 in this column here. Let's continue. So we got a, from 4x cubed I got a plus 4 in a x cubed column. Let's continue here. From plus 3x squared I got a plus 3 in a x cubed column. Let's continue here. From plus 7x I got a plus 7 in x column. Let's continue. From minus 6 I got a minus 6 in a constant column. Let's continue here. From minus 7, minus times minus is plus. That give me plus 7x cubed, and I got in this column here. That's a minus, and plus is a minus, so minus 9x squared. This is minus 9x squared, and I got a minus 9 in x squared column. Let's continue. Now I got this plus 6 here, and plus 6 and times minus is minus. This is minus 6. Minus 6 comes in this column, okay, in a constant column. Now what we do, we would add in columns. That gives me a, okay, first column x cubed column is 11, total 4 plus 7. X squared column is 3 minus 9 is minus 6. X1 column is plus 7. And x0 column is minus 6, which is 12. Minus 12. Okay, let's continue. That means that I got E1 minus E2 is equal to 11x cubed minus 6x squared plus 7x minus 12. Let's continue. Let's do some exercises now. We would try to find our E1 plus E2 and also E1 minus E2. First exercise is E1 is equal to minus 4x cubed and E2 is equal to minus 7x cubed. Flag value is 3, and coefficients are minus 4 and minus 7. Okay, this is one term and one term. On E1 has one term and E2 also have one term. These are cubic expressions though. X cubed and minus 4x cubed minus 7x cubed. Let's continue here. Now get another one here, minus 7x E1, E2 is 8, which is constant. This is a flag value 1 and E2 has a flag value of 0. Let's continue. Another one, E1 is 3 times x4. This is 3x fourth power of x times 3, and is fourth power x times 4 is a 4x to the raised to the power of 4. Okay, let's continue here. Next is E1 has two terms here, two terms here. 4 plus 2x cubed has flag value 3, this is flag value 0. Flag value 3 here, 9x cubed and minus 8x, flag value is 1. And we have to compute both E1 plus E2 and E1 minus E2. Okay, next one has more terms now. It's x cubed minus 4x squared plus 4x, that's E1. And E2 is 6x cubed minus 4x squared minus 7x. Let's continue. Another example here, and some more. If you want to look at some more, check out the khanacademy.org, math, algebra, and also you can check out this regentsprep.org/regents math algebra AV2 extracts. You can check that up. I usually use the random number generator to make up these E1s and E2s, so you can also use a random number generator to compute your expressions. Let's continue. Go to next section here, which is a multiply. Okay, let's continue. Okay, let's go do some multiplications here. Sutra is add flags and multiply numbers. Flags are the power value and numbers are coefficients. So let's see what I mean by when we're trying to multiply monomials, let's say called single terms. We add flags and multiply the coefficients. Okay, let's continue here. So let's look at example here from the number math. 3 times 6, and this 3 is actually equal to 3 times 1, which is the 0th power x. Same thing is 6 is 6 times 1, and 1 is a 0th power of x. Okay, let's continue here. Now if I add flag values, a 0 plus 0, 0 here and a 0 here, which is 0. Multiply coefficient, which is this is coefficient 3 and 6. 3 times 6 is 18. Okay, so 3 times 6 is 18 times 0th power of x, which is 18 times 1 equals 18. So we can use algebra and go into 0th power of x, etc., and we still come back 3 times 6 is 18. Okay, so you can consider this to be algebraic expression and this is also algebraic expression when there are no variables involved. Okay, it's just all constants. Let's continue here. So now we will do another example here. 5x times 17x squared. Flag is 1 here and flag is 2 here. 1 plus 2 is 3, so I got a flag value of 3 in the result. Coefficient is 5 here in the first operand and 17 in the second operand. So multiplicand has a coefficient 5, multiplier has a coefficient of 7. 5 times 17 is 85, so coefficient of result is 85, flag is 3, result is 85x cubed. Let's continue another example here. 3x squared is a multiplicand and 13x squared is the multiplier. So flag value is 2 plus 2 is 4, so the x fourth in the result. And coefficients are 3 times 39, which is 3 times 13 is 39. Let's continue here. So the result is 39 times x fourth, x to the 4th power. Let's multiply with a constant. So multiplication sutra is add the flags and multiply coefficients. Flag value of constant term is 0. That means the flag value does not change. Okay, we can add 0 to anything and it still stays the same value. 0 is my additive identity and it does not change the value of the number it was added to. Let's continue. So we are going to multiply by 3 and this expression is 3x to the 5th power plus 7x squared plus 4x cubed. Continue here. So 3 times 3 is 9 and flag value stays same. So 9x to the power 5 3 times 7 is 21, so 21x squared for the second term. For third term, 3 times 4 is 12, 12x cubed here. Okay, let's continue. So it's equal to 9x to the fifth power, 21x squared plus 12x cubed. Let's continue here. Another example is 13 times 2x cubed plus 5x squared plus 9x plus 17. Let's continue. 13 times 2 is 26, 26x cubed. 13 times 5 is 65 plus 65x squared. 9 times 13 is 117, so plus 117x. 13 times 17 is 221, so it is plus 221. So 13 times the other expression is 26x cubed plus 65x squared plus 117x plus 221. Let's go. Now we will try to multiply with a single term here. 3x, we are trying to multiply 3x by x squared plus 5x plus 4. So x has a flag of 1, so flag value would get added. First term of the result would have flag value of 3, second term would have flag value of 2, and third term would have a flag value of 1. Let's continue here. So it is the first term is 3 times 1 is 3, and flag value is 3, 3x cubed. 3 times 5, 15x squared. 3 times 4, that's 12x. Okay, continue here. Another example here, we are going to multiply by x. The expression is x cubed plus 3x squared plus 3x plus 1. Okay, so we just keep adding the flag. Coefficient is 1. Multiplication, we can just skip multiplication. We just say it's same. So x fourth plus 3x cubed plus 3x squared plus x. Let's continue here. 5x cubed times 2x squared plus 5x minus 3. So it's a flag value is 3. So we would add for the first term 3 plus 2 is 5. Flag value is 5. For the second term flag value would be 3 plus 1 is 4. For third term flag value would be 0 plus 3. Let's multiply now. 5 times 2 is 10. So we get 10x to the power of 5 plus 5 times 5 is 25. 5 times 5, 25. And flag value is 4x fourth. And this is 1 here and a 3 here. Then 5 times minus 3 is minus 15 here. And flag value is 3 here and a 0 here. 3 plus 0 is 3. So x cubed. Answer is 5x cubed times parenthesis 2x squared plus 5x minus 3 is 10x to the fifth power plus 25x to the fourth power minus 15x cubed. Let's go. Now we're trying to multiply with linear terms here. We still do that, add the flags and multiply coefficients. Let us see what the linear term I mean by. So x plus 7 is a linear term. X plus 7, and this is my multiplicand, and x minus 3 is my multiplier. Okay? Let's continue here. So we would divide that into two multiplications, like x plus 7 times x minus 3 is equal to, first we will multiply the multiplier with the x part of the multiplicand, then with the plus 7 part. So it would be x times the multiplier plus 7 times the multiplier. Let's continue here. So that would be give me x squared minus 3x plus 7x from here, and minus 21 from here. 7 minus 3 21. X times x squared. X times minus 3 is minus 3x. Now minus 3x plus 7x will combine into one term. So now we're going to collect terms here. We just collect x squared under x squared column, minus 3 from x under x1 power x1 column. This plus 7 also in same column here. Then minus 21 in the x0 column. Okay, let's continue. Let's add in columns. So we get plus 1x squared plus 4. 7 minus 3 is 4 x and minus 21 here. Okay, let's continue. That means that x plus 7 times x minus 3 is x squared plus 4x minus 21. Let's repeat that with different method here. Okay? We'll use a base multiplication, and we use that for number math, and this is the video if you want to look at it. But let's go do that. Base is x. So base numbers are in number math were 10, 100, 1000, etc. Power of 10, and here are powers of x. Okay, so base number is x. So what we do is we write down the two operands, multiplicand and multiplier, in two rows. Okay, then we draw a vertical line to the right. Then we write plus 7 here. Plus 7 is anything excess of x in the multiplicand, and I got 7 from x plus 7, the multiplicand, minus x, which was the base. Okay. For next line, I have minus 3 here. Excess of x was minus 3 here in the left side, and I got a minus 3 from x minus 3, the multiplier, and minus the base. Okay, x minus 3. Now the multiplication. We draw horizontal line here. We do that in two parts, left and the right part. Okay. For the left part, which is comes in here, we do apply crosswise. Okay, so we're going to do x minus 3 plus 7, or x plus 7 minus 3. So we would do crosswise apply the right side. I call deviations in that video I mentioned here. So right side is deviations. So I applied the cross deviations, x minus 3 plus 7, or x plus 7 minus 3. So on the left side I got an x plus 7 minus 3, or x minus 3 plus 7, which is x plus 4. Okay, let's continue. On the right side, I multiply vertically. 7 minus 3 plus 7 times minus 3 is minus 21. Okay, let's continue. So we got x plus 4 on left side and minus 21 on the right side. Let's see how do we now go about doing the multiplication. Let's continue here. And this product here, x plus 7 times x minus 3, is left part, which is that, times base. Base is this one here, plus the right part. So if I do that, I get x squared plus 4x minus 21, which is the same number we got before. Okay, let's continue. Do another method here. Now this time we will do vertically and crosswise multiplication. This is general method of multiplication, and it's shown in this video for the number math. So we write down these two, x plus 7, x minus 3, two operands, and I draw a vertical line here. Let's see what I want to do here. First of all, I know that this is flag value 1, this is flag value 0, flag 1, flag 0. And if I multiply left by left, I get flag of 1 plus 1, which is 2. This is my highest flag value, which is I got from left by left. Okay, which is 2, and the lowest flag value is from right by right. So the 7 minus 7 is flag value 0, and this is a flag value 0. This is a flag value 1, flag value 1. When I multiply these two terms together, I get a flag value of 2. When I multiply these terms together, I get a flag value of 0. Okay, and lowest flag value is from right by. Okay, then that means that I need a x squared column, x1 column, x0 column, because I would get something for x squared. I know that x times x is x squared. So, and also I know I get some constant term here, plus 7 minus 3. Let's continue here. On left, multiply vertically, which is 1 times 1. I'm going to multiply the coefficients here, which is 1. So I got 1x squared. Now I'll show you that multiplication is symmetric, so I just did a term on left. Now I would do a term on the right. Let's continue here. On the right, we multiply vertically, plus 7 times minus 3, which gives me minus 21. Now the middle term here, I apply crosswise and add. So this is crosswise like this and crosswise like this. So 1 minus 3 is minus 3 plus 7 times 1 is 7. So minus 3 plus 7 is plus 4. So my middle term is plus 4. Multiply crosswise and add, which is 7 times 1, this one here, and minus 3 times 1, which is 4. Okay, that means I got a value product of x squared plus 4x minus 21. Let's continue. That means my product is x squared plus 4x minus 21. X squared from here plus 4x from here minus 21 from here. Let's continue. Now we'll do another example here. 3x minus 7, this is multiplicand, this is multiplier, and it's split in two products here. 3x times x plus 13, 3x part and multiplier, and minus 7 part and multiplier. Okay, let's continue here. So left is 3x squared, 3 times 13 plus 39x, right is minus 7x and minus 91. Minus 7 times 1x and minus 7 times 13 is minus 91. Let's continue here. So we'll combine these two together. X has a 39x and minus 7x. Okay? So I got 3x squared plus 32x minus 91. So we multiplied them together and I got, this is the answer I got. Okay, let's continue. Okay, let's repeat the example again. Multiplicand is 3x minus 7 and multiplier is x plus 13. Okay, let's continue here. So we'll do a vertical and crosswise method here. Okay? So we did 3x minus 7 multiplicand, and this is my multiplier x plus 13. Highest flag value is 2, which is 1 plus 1 here, left by left, and lowest is 0. 7 and 13 are both constants. Okay? Continue here. And lowest flag value is 0. That means I would have it terms with the second power of x, first power of x, and 0th power of x. Okay, let's continue here. So on left I will do left by left. 3 times 1 is 3, which is vertically though. Vertically here. Then I go to right to show symmetry here. On the right it's a minus 7 times 13, which is a minus 91. It's vertically again. In the middle it's a crosswise and add. 3 times 13 is 39, minus 7 times 1 is minus 7. 39 minus 7 is plus 32. Let's continue. In the middle it's multiply crosswise and add. Crosswise 3 times 13 and minus 7 times 1. 39 minus 7 is 32. Let's continue. So plus 32. So I got a 3x squared plus 32x minus 91 as the answer. Let's see what happens. That means that this multiplicand times multiplier is 3x squared plus 32x minus 91. Let's continue here. Repeat the example again. The question is, can we use base multiply? Sure, it's best to have the base same base, and to get the same base we would do a 3x. Base is 3x, multiply second operand by 3. This one has a base x and this one has 3x. So we want to make this one also, second multiplier also have a 3x. So what we do is we multiply first by 3 the multiplier. In the end we would divide the result by 3. So we would do by multiplication and division of by 3. Let's continue. So here is my multiplicand, and this is my 3 times the multiplier. Okay, let's continue here. On the right I got minus 7. My base is 3. Continue. And I got 7 from, minus 7 from the multiplicand minus base, which is minus 7. Okay. And the right side of second line is plus 39, which is, I got that from 39 is excess from the base. Okay, so which 39 is the multiplier 3x plus 39 minus the base 3x. Okay, let's continue here. On left we apply crosswise the deviation. On left we apply crosswise, which is 3x plus 39 minus 7, or 3x minus 7 plus 39, okay, which is either 3x minus 7 or this way plus 39, or this way 3x plus 39 minus 7, okay, which is 3x plus 32. So left is 3x plus 32, and right we multiply vertically, which is minus 7 times plus 39 is minus 273. Let's continue here. And 3 times the product, we have multiplied the multiplier by 3 is the base 3x times left part 3x plus 32 minus from right side, it's 3 times 91. We have to divide by 3. Okay? So product is, we divide that by 3, multiplied inside by x, 3 this 3 here, x squared plus 32x minus 91. This 3 gets, we divide this 3 times product by 3, so with this 3 become 1 and this 3 become 1. Okay, so product is 3x squared plus 32x minus 91. Let's continue some exercises. Multiply E1 and E2. So first example is E1 is 3, E2 is 15x. Next example is 3x squared is E1, E2 is 17x to the power 4. Next is E1 is minus 6x plus 17, and E2 is 3x minus 11. Let's continue here. E1 is minus 3x and E2 is 7x plus 6, and so on. Okay. For more examples, you can check out this website here, or you can use the random number generator to make some more examples. Let's continue. All right, let's multiply quadratics. Let us see what the quadratics are again. For quadratics, base multiplication gets cumbersome. It still works though. We will only use conventional and vertically and crosswise methods. So either we would use conventional method or vertically and crosswise method. Okay, let's continue here. Example is E1 is 3x squared plus 5x minus 7. E2 is 4x squared minus 3x plus 2. So highest flag value is 2 and highest flag value is 2, and that's we call quadratics. Let's continue here. So E1 times E2 is, we would start multiplying 3x squared first term of the first expression by the whole of the second expression. So plus 3x squared times 4x squared minus 3x plus 2. Okay, let's continue here. And then plus 5x times the second expression, 4x squared minus 3x plus 2. Let's continue. Then minus 7 times the second expression, 4x squared minus 3x plus 2. Okay. First of all, we know that largest flag value is 2. Largest flag value is 2 of the product. Largest flag value is 2 plus 2, which is 4. And smallest flag value is here, 0 here and 0 in this term. 0 plus 0 is 0 plus 0 is 0. So lowest flag value is 0. So we should have terms for fourth power of x, third power of x, second power of x, first power of x, and constant terms. Let's continue. Now we will start to collect these terms here under the various columns here. The first one is 3 times 4, which is 12, and flag values add 2 plus 2 is 4. So 12x fourth comes, we will have a 12 under the x fourth column for this term here. Let's continue here. That means that I got plus 12 and I don't have this 4x squared times 3x squared anymore. Okay? Now 3x squared minus 3x would give me minus 9x cubed. So x cubed is column here. So we would have minus 9 for this product for minus 3x times 3x squared under x cubed column. Let's continue here. So we got a minus 9 here, and we used up this term here. Now 3x squared times 2 would get me a 6x squared. So we'll have a plus 6 under the x squared column for this product. 3x squared times 2. So, okay, we used up this product. Now we would start collecting terms from the second product here, 5x times this expression, second expression. Let's continue here. 5 times 4 is 20 as x cubed. So we'll have a plus 20 under the x cubed column. Okay, so we got plus 20 under the x cubed column. Okay, now 5 times minus 3 is 15, 15x squared, minus 15x squared. So we'll have minus 15 under the x squared column. Okay. 5x times 2 is 10x. So we'll have a plus 10 under the first power of x. Let's continue here. Now, so we have used up 3x squared times the second expression plus 5x times the second expression. Now we are left with the minus 7 times the 7 expression. Minus 7 come from here. Okay. Minus 7 times 4 is minus 28. It's x squared. Okay, so we got minus 28 x squared. Minus 7 times minus 3 is 20 plus 21 and x. So we got a plus 21 under this column here. Okay, now minus 7 times plus 2 is minus 14. It's a constant term. We get under this x0. Okay, we got x minus 14 here. Let's continue. Now let's add them up in columns. So we got plus 12x fourth plus 11x cubed. It's a plus 6 minus 15 is minus 9, minus 9 plus minus 28 is minus 37. So minus 37x squared. 10 plus 21 is 31 plus 31 xx and minus 14. Now let's look up again. We have one product being added up in x4 column, 2 in x cubed column, and 3 in x squared column, and a 2 in x1 column, and 1 in x0 column. So one product here on the right, one product here on the left. Two products being added up here and on the right, two products being added up in on the left, and in the middle we have 3 products being added up. Okay, so that you know symmetry is one product and one product, 2 products here and 2 here and 3 here. First, from left, if we start from left, we are ramping up from 1, 2, and 3, and then we ramp down 2 products and 1 product. Let's continue. That tells me the product is 12x fourth plus 11x cubed minus 37x squared plus 31x minus 14. Let's continue. Let's continue. We would repeat the same example. This time we would use vertically and crosswise. Again, E1 is 3x squared plus 5x minus 7. And second expression is 4x squared minus 3x plus 2. Let's continue. Now here are the two expressions here. 3x squared plus 5x minus 7. Here 4x squared minus 3x plus 2 written, one on the first line and second on the second line. Let's continue here. Highest flag value comes from multiplying these two terms. This is a flag value 2 and a flag value 2. 2 plus 2 is 4. Highest flag value is 4. And lowest flag value comes from multiplying minus 7 and a 2, which is a flag value 0 here and flag value is 0 here. 0 plus 0 is 0. Let's continue. That means that we would have a terms for fourth power of x, x cubed, x squared, and x, and a constant term. Let's continue here. So leftmost is where the one product, and they come from one column. On the leftmost column, 3 times 4 is 12, and it's x fourth, where we would have a plus 12 in the x fourth column. Okay, let's continue here. The plus 12. Now we will do the rightmost here. Rightmost come from minus 7 times 2, which is minus 14. It's vertically, and only one column is used. This column here is being used here vertically. So we got a minus 14 under the constant term here. Okay, let's continue here. Now we'll come back to x cubed column, in which you have a two products, and two columns would require two columns on left. So we'll use this column and this column here. Okay, so it's crosswise and add. 3 minus 3 is 3 times minus 3 is minus 9. 4 times 5 is plus 20. Minus 9 plus 20 is plus 11. So we have plus 11 in the x cubed column. Let's continue here. Now we will do x1 here. X1 is there one product here, and we will have two products in the x1 column, first part of x. Two products from the right. So we'll have these two columns being involved, this column and this column. So 5 times 2 is plus 10, and minus 7 times minus 3 is plus 21. 10 plus 21 is plus 31. So we'll get an a plus 31 in x1 column. Okay. Let's continue here. Now for x squared, we'll use all three columns here, and we'll have vertically and crosswise. Here's crosswise, here's vertically, and here crosswise. Multiply crosswise, 3 times 2 is 6. Next, multiply vertically here, 5 minus 3 is 15. 6 minus 15 is minus 9. Then here minus 7 times plus 4 minus 28. But minus 9 minus 28 is minus 37. So we have minus 37 in the x squared column. Let's continue here. So product is E1 times E2 is 12 x fourth power of x plus 11 cubed minus 37 x squared plus 31 x and minus 14, just like before. Let's continue. Previous example. So E1 is we'll say base multiplication. We need same base. For that you will need to multiply E1 by 4 and E2 by 3. So we'll use a 12x squared as base, and we'll get in a multiply E1 by 4 and E2 by 3, and in the end we will divide the product by 12. Let's continue. You'll find that for quadratics and higher degree polynomials, vertically and crosswise is the best method. Let's get an example. We'll take it. E1 is 2x squared plus 3x plus 0. Please note that 0 here, and you better fill in the ranks of the missing term by using a 0 coefficients. Okay, E2 is minus 3x squared minus 4x plus 4. It's a quadratic here. It's quadratic 2. Highest power in flag value is 2 here. That's quadratic. Highest flag value is 2 here. That's also quadratic. Let's continue here. So we'll write on again. We only need the coefficients here. Okay, 2 plus 2 plus 3 plus 0 from the E1, and minus 3 minus 4 plus 4 from the E2. Let's continue here. Highest flag value is 4. We come from 2 times 2 plus 2 here, 4. And lowest flag value come from 0 plus 0. When you multiply right term by right term, I get a 0 low flag value, that's 0. Okay, that means that I will have a x to the fourth power term, and x cubed term, x squared term, x term, and a constant term. Let's continue to multiply here. Leftmost column in here, we will have multiply plus 2 times minus 3. We'll use this column here, and I get minus 6. Okay, rightmost column. So you have to do first leftmost, then rightmost, to make sure you know that, understand there's symmetry here. And rightmost will do use this column here, 0 times 4 vertically, which is 0. Okay, let's continue. Now in x cube column, now we go back to left here. We'll have two left columns here. 2 times minus 4 is minus 8, plus 3 times minus 3 is minus 9. Minus 8 minus 9, so we have minus 17 in x cube column. Let's continue here. Now we'll do a column on the right. We'll do x1 column here. We would use two right columns. 3 times plus 4 is plus 12. 0 times minus 4 is 0. So we have 12 minus 0. So we have a 12 x1. Okay, in the middle here, we'll use all three columns. In x square, vertically and crosswise, all three columns. 2 times 4 is 8. 3 times minus 4, this is vertical, it was crosswise here. 3 times 4 minus 4 is minus 12. Plus 8 minus 12 is minus 4. And this one is 0. So minus 4 is under x squared. Okay, and so we get a, so E1 times E2 is minus 6x to the power 4 minus 17x cubed minus 4x squared plus 12x plus constant 0. Okay, let's continue. That means E1 times E2 is minus 6x fourth power minus 17x cubed minus 4x squared plus 12x. Let's continue. Now we'll do example of moving multiplier. Let's continue. So here E1 is 5 times x to the fourth power plus 3x cubed minus 1x squared plus 4x plus 5, and E2 is minus 3x squared minus 4x plus 4. Let's continue here. Let's do example from straight math multiplication example, which is a straight numbers example, number math. Okay, so we have 5 terms here and 3 terms here. So 5 multiplicand has 5 terms and multiplier has 3 terms. So 1, 2, 3. Let's continue here. So first we multiply this digit, rightmost digit of the multiplier with every digit of the multiplicand. We get 5 products in the first row. Then we get 5 products in second row from second digit of the multiplier, multiplying each digit of the multiplicand. Then we get a third row by when we multiply this digit of the multiplier by average digit in the multiplicand. Okay, then we're gonna add them up and worry about take care of all the carries required. So A, B, C, D, E, F, G. A might have be 2 digits. Okay, and every other digit is B is one single digit, C is single digit, D is a single digit, E is single digit, F is single digit, G is a single. Now what I'm looking for is in the rightmost column there is a one product being added up, and when we do vertical and crosswise we'll do one column, and in next column we have a 2 products and they would come from multiplying 2 columns. In the third column we have a 3 products here, okay, and they will come from vertically and crosswise of 3 columns. This fourth column has the 3 products. They come from vertically and crosswise of 3 columns, and these products are different from this product. Okay? Now these are also in a fifth column. Also we have a 3 products. They come from in vertically and crosswise. They would come from multiplying vertically and crosswise 3 columns. Okay. Now we get a 2 products here. They come from leftmost 2 columns, and this one come from one product. It comes from vertically on the leftmost column. Let's continue here and do this example we were talking about. Okay, so highest flag value is 6, 4 here, flag value, and 2 here. And lowest value is constant term here and a constant term here. They both have a flag value of 0. 0 plus 0 is 0. Okay, that means this is what we're looking for. We have a sixth power of x, fifth power of x, fourth power of x, x cubed, x squared, x, and a constant term. These are the terms we would expect in the product. Let's continue here. And this is the, now multiplicand is plus 5 plus 3 minus 1 plus 4 and plus 5. Multiplier is minus 3 minus 4 and a plus 4. Okay, let's continue here. Okay. Sutra is vertically and crosswise. Okay, that's what sutra is. Okay, let's continue. Okay, on the rightmost, we start from right to left now. On rightmost or leftmost column, we use one product and they come from one multiplier, one column. So we'll use one column and it's vertically here. So 5 times 4 is 20. 20 is my result in a constant term here, which we did vertically here. 5 times 4, 20, and it's vertically comes in a constant term. Let's continue here. Now we are ready to, we already got plus 20. We are ready to move into one column to the left on x term here. We'll use two columns to multiply. So we will get an 4 plus 4 and plus 5 from a multiplicand, and minus 4 and plus 4 from the multiplier. So multiply them crosswise and add. Plus 4 times plus 4 is plus 20, and 5 minus 4 is 5 times minus 4 is minus 20, which is 16 minus 20 is a minus 4. X1 term is minus 4. Let's continue here. So X1 term is minus 4. Here we will right leftmost but one column to the right of left, or one column to the right of the leftmost is we need two columns to multiply and two products, and these are the products we multiplied, and I got a minus 4. So we got a minus 4 here. Let's continue here. We will move into the third x squared. Okay, this is how far so far. Now we are ready to use all three columns here. Okay, minus, we'll do use this column, this column, this column, and sutra is crosswise. Minus 1 times plus 4, which is minus 4. Next is 4 times minus 4 is minus 16. So minus 4 here and minus 16 here, which is minus 20. Then 5 minus 3. 5 times minus 3 is minus 15. So minus 4, minus 16, and minus 15. Minus 4, minus 16, add them up together, minus 20, and then add these together, become minus 35. Let's continue here. So 2 from right or 2 from left column needs 3 products. So we get 3 columns, and the results is x squared is, we just say minus 35. Let's continue here. So minus 35. Now we are ready to move into the x cubed column. Let's find out what's. So far we have been adding a column to the left. First we did it in this column, and then that column added, then we added this column. Now at the most we can have 3 columns, because 3 is the number of digits in the multiplier, okay, which is a smaller. Multiplicand has 5 digits and multiplier has 3 digits. Okay, we have we have not yet used 2 of the columns from the multiplier. Okay, now we will pick up a column, and remember that we had one product, two product, and 3 products being added up, and then 3 products being added up here, and 3 being added up here, then 2 in this x5th column, and 1 in x6th column. So we still need to add 3 products here if we need to, because that's where my cartoon is at. So, and I can't use these columns here. We already used these columns, but I have to keep using these columns because these columns have not yet interacted with these 2 columns here. Okay, so we would drop a column here of the multiplicand, and pick up a column of the multiplier here. Okay, let's continue. Okay. Multiplier has only 3 columns and can interact with at most 3 columns of the multiplicand. Okay, multiplier 3 columns, at the most it can interact with 3 columns of the multiplier. These 3 it has already interacted with. Now we go to start interacting with this column and also with this column. Okay, let's continue. We will pick up a column on left. We'll pick up this plus 3 and drop this plus 5. Okay. So we just move this multiplier to the left. Now we are in x cubed column and we have 3 products to worry about. This one, this one, and this one. This is crosswise, vertically, and crosswise. Okay, let's continue here. From previous, we have 3 products in x cubed column, and the necessary results in that column is plus 3 times 4, which is plus 12, minus 4, 1 times minus 4 is plus 4, 12 plus 4 is 16, and then 4 minus times minus 3 is minus 12. So 16 minus 12 is 4. So 4 is, we have 4 in x cubed column. Let's continue here. Let's continue. Now we'll move that a little further again. Okay, one more term. Now we'll compute x fourth term here. Okay, let's continue. We have 3 products in x fourth column, and the necessary result is that 5 times 4 is 20. 3 times minus 4 is minus 12. 20 minus 12 is 8. And then minus 1 times minus 3 is plus 3. 8 plus 3 is 11. So we have 11 in x fourth column. Okay. Let's continue. Okay. All right. We have already computed x fourth now, and we have already used up all the digits in the multiplicand and all the digits in the multiplier. We now will start dropping columns on the right. X5 has sum of 2 products. That's what we saw in the cartoon we discussed before, and these 2 products are these one, 5 times minus 4 and 3 times minus 3. Okay, let's continue here. So we use all the columns on the right from both operand and need to start dropping columns on the right. Okay, and you can compare the examples in the cartoon we did for the straight math method. Okay, and so it is 5 times minus 4 plus 3 times minus 3, minus 20 and minus 9, which so minus 29 is the coefficient of x to the 5th power term. Okay, and that's minus 29 and that's minus 29. Now we are at the, we have computed coefficient of x 5th power. We have to compute 6th power, which comes from one product, which comes from this product here, 5 minus times minus 3. 5 times minus 3 is minus 15. Let's continue here. Okay, and so it's minus 15 here. Let's continue. And so E1 times E2 is minus 15 x to 6th power minus 29 x to the 5th power plus 11 times x to the 4th power plus 4 x cubed minus 35 x squared minus 4x plus 20. Hint, we'll do some exercises now. If the missing term is there, use a 0 for the term. So 2x squared is E1, E2 is 2x squared minus 5. Continue. So we're going to multiply these E1 times E2. Find E1 times E2 for these. E1 is the A2x squared, E2 is 2x squared minus 5, and next is E1 is 2x squared minus 5x minus 4, E2 is 4x minus 3. Okay, you can use 0 for the x squared term here. Okay, continue here. E1 is minus 2x squared minus 3x plus 2, E2 is 5x squared minus 5x plus 1 and some more. Okay, and for more examples, use random number generator to construct more examples. That's what I used for these example exercises too. All right, let's continue with next section here. Next section is about dividing. Let's look at sutra here. Sutra is subtract flag and divide the coefficients. and applies to monomials. Okay, let's continue here. In division problem domain, in division there are problem domain and solution domain. In problem domain quantities are dividend and divisor. These in a problem, these are invariant. Uh, Dividend and divisor are invariant. That's part of the problem domain. Division is given by dividend divided by divisor, and it's just like a fractions where we might have an improper fraction. If you look at dividend divided by divisor, we might get into this might be a improper fraction. Okay, let's continue here. In applying the sutra, both the dividend and divisor may be algebraic expressions. Okay, and we have algebraic expression we're dealing with. Sutra applies when both the dividend and divisor are monomials. This sutra applies when both the dividend and divisor are monomials. That means consist of a single term. Let's continue. According to sutra, we divide the coefficients and subtract flags. So divide the coefficient of the dividend by that of the divisor and subtract flag of the divisor, this one here, from that of the dividend, subtract flag of the divisor from flag of the dividend, and divide coefficient of the dividend by coefficient of the divisor. Let's look at some examples for division. Okay. So expression E1 is 3x squared, and we are trying to divide that by 5. Okay. The coefficient is 3 in the dividend, coefficient is 5 in the divisor, flag is 2 in the dividend, and flag is 0 in the divisor. Let's continue here. So answer is 3 divided by 5. That's the coefficient part of the answer, and x squared is the x part of the answer. So the flag value is 2, and hint, in case you didn't see it, 5 is equal to 5 with x to the 0th power. Let's continue. And you can refer fractions here. We are using fractions here, and we did a video on fraction, and that is the link to that video. Let's continue here. Let's do another one. E1 is equal to 34 times x to the 5th power, and E2 is 85 x cubed, and we had to find E1 divided by E2. Okay, let's continue here. Coefficient is E1 is 34 and that of E2 is 85. Let's continue here. And coefficient of E1 divided by E2 is 34 divided by 85, and it's a 2 divided by 5. Okay, 17 is a common factor. You can cancel out. Let's continue. And flag of E1 divided by E2 is 5 of E1 and a 3 of E2, and it's 5 minus 3 is 2. Okay, that means E1 divided by E2 is 2 divided by 5 is the coefficient, and x squared is flag of the x term is 2, which is x squared here. Let's continue here, and let's look at another example here. E1 is 3x cubed plus x squared minus 6x, and E2 is 4x. Let's continue. So we'll have a 3x cubed divided by 4x plus we would divide even at 4x, we would divide by 4x every term one at a time. This 3x cubed monomial, other monomial, next monomial, okay. So then next is 1x squared divided by 4x minus 6x divided by 4x. Okay, let's continue here. That gives me a 3/4 of x squared, 1/4 of x from here, flag 2 and flag 1, flag 3, flag 1, 3 minus 1 is 2, that's 2 here, flag 2, flag 1, that's 2 minus 1 is 1, and this is a flag 1, and flag 1 is minus 6 divided by 4 is 3 divided by 2. Let's continue. Let's do some examples here. If you need more examples, please look at the slide here, this link here, www.education.com/slideshow/dividing hyphen monomials /dividing hyphen monomials -1. Okay, let's continue. Let's do some exercises. Determine E1 divided by E2 in the following. E1 is 27 times x to the 5th power and E2 is 999. Let's continue here. Next example is E1 is 78 x cubed and E2 is 26. Let's continue. Another example is E1 is 51 x squared, E2 is 85. Next, E1 is 95x and E2 is 76. Next, E1 is 63x and E2 is 77. Let's continue. Another one is E1 is 143 times x to the 7th power and E2 is 121. Let's continue here. E1 is 85 and E2 is 65. Let's continue. E1 is 18 times x to the 6th power and E2 is 24. Let's continue. E1 is 12 times x to the 0th power and E2 is 30. Let's continue. E1 is 15 times x and E2 is 25. Let's continue. E1 is 27 times x to the 5th power and E2 is 999x. E1 is 78 times x cubed and E2 is 26 times x squared. E1 is 51x squared and E2 is 85x squared, and some more examples. Okay. Let's do an example of division by a linear term. Okay, let's continue. So E1 is x squared plus 2x plus 1 and E2 is x plus 1. X plus 1, I call it, this is a linear term because the highest power of flag value of a monomial in this term is 1. That's linear. And highest power of flag value is 2 in E1. So this is quadratic. Let's continue here. We'll set up the problem like this. This is my dividend and this is my divisor. A quotient would come in the top line here and remainder would come in the bottom line here. Our working remainder or working next dividend. Okay, let's continue here. So first let's find out which quotient I'm going to use. This is x squared here and it's x here. It's just that x squared divided by x is x, so we'll use a quotient of x. Okay, from that I would have to take out x times the divisor. We'll subtract that from the dividend. Let's see what happens. So we'll subtract x time, which is my quotient digit I just used, times the divisor from the dividend. Dividend is right here. Okay. So we subtract minus x squared. X times x is x squared, and we are subtracting. And x times 1 is x. We're subtracting that minus x. Okay. Okay. X squared minus x squared is 0. So there is a 0 for the x squared term, and x term is 2x minus x, which is a 1x. Let's continue here. Next dividend is x from the remainder, and then use the rest of the dividend x plus 1. Okay. So next dividend digit is x plus 1 in the next working dividend and x plus 1 as a quotient. So next quotient digit is 1. Okay. And so that's the next. Then you after that subtract 1 times x plus 1, 1 times from x plus 1, and I got 0 all the way around. Okay. So subtract that, I'm going to 0. Okay. And answer is x plus 1. That's my quotient, and the remainder is 0. Okay. Okay, let's continue and let's revisit that. Again, now E1 is x squared plus 2x plus 1, and E2 is x plus 1. Let's continue here. we'll use sutra by completion. What are we going to complete? Multiples of the divisor. Remember that we have to subtract out groups, make up groups of the divisors, how many groups we have, and we would do the same thing here. From the E1, we would use sutra by completion. We complete a groups of x plus 1 and subtract that out from E1. Let's continue here. So we'll extract groups of x plus 1 from the dividend, which is x squared plus 2x plus 1. Let's continue here. Mechanism will be completing multiples of x plus 1. Let's continue here. So we have x squared here. This is x times x, and I need x plus 1 times x to make a groups of x plus 1. Okay, so let's see what I do here. So first I split that 2x into x plus 1, and my intent is trying to make a groups of x plus 1. For first two terms, I get a groups of x plus 1. Okay, let's continue here what I mean by. So from first two terms, I have x groups of x plus 1. If you don't see, cannot visualize what I'm talking about, assume x is 10, so that you can, because we said that numbers and algebraic expression are similar, and if x were equal to 10, they are equivalent. Okay, let's continue. So I just made a x group of x plus 1, and then there's one more group here of x plus 1. Okay, so when I take one more group of x plus 1 out from here, there's the remainder is 0. Let's continue here. That means that I have a x plus 1 groups of x plus 1. So when I divide E1 divided by E2, there are x plus 1 groups of the divisor. Okay, so answer is x plus 1, and remainder is 0. Okay, I didn't show the remainder, but 0 is the remainder. Let's continue. Let's revisit that again, and this time it's still E1 is x squared plus 2x plus 1, and same example, E2 is x plus 1. Let's continue. This time we will use sutra, transpose and apply, and for reference to how we apply that in a number math, here is my video we did for transpose and apply method of division. Let's continue. It's like dividing by 11, x plus 1. We said x is like 10 when we were comparing a number in decimal number system to an expression in algebra. Base is x and surplus is 1. Okay, and transpose of that is minus 1. So let's see how do we write up the equation problem here, set as problem. With two-step division, we'll do two-step division, which is x times 1, base is x times 1. First we divide by x, and then second by 1. Let's continue here. I've set a problem like this. X plus 1 is my divisor, and transpose is minus 1. And x squared plus x, I got these columns here, x squared column, x1 column, and x zeroth column, and 1x squared, 2x squared, and 1. So that is my dividend here. Let's continue here. Highest flag value is of the answer is 2 minus 1. 2 flag value here and 1 here. Okay, and lowest flag value is 0 here and a 0 here. 0 by 0. Okay, let's continue here. Divide by x, our first division. Let's see how we do that. Okay, so we draw this line here, and if we were to divide x squared plus 2x plus 1 by x, we will get it x plus 2 remainder 1. So that we just did divided by x. Okay, let's continue here. And then we divide in first column by 1. We divide this 1 by 1 and adjust. Okay, so we get plus 1 here, and transpose is minus 1. 1 times minus 1 is minus 1. Adjustment in next column is minus 1. Let's continue here. So minus 1 here, and then 2 minus 1 is plus 1 here. Let's continue here. Plus 1, we divide plus 1 by the second division again, and that is this plus 1 we divide by 1, which is plus 1, Now adjust in next column. 1 times minus 1 is a minus 1 adjustment in the next column. Okay, and that gives me a 0 in the total in the remainder column here. Let's continue here. Then E1 plus divided by E2 is x plus 1. X here, x1. A constant term is plus 1. X term is 1. X plus 1, remainder 0. All right, let's look at some observations here. We have divided by three different ways now. Okay, we divide E1 by E2, where E1 was quadratic and E2 was a linear expression by conventional method, okay, and then which is long division method. By completion of sutra, which is completing multiples of the divisor, okay, which is extracting the groups of the divisor, and by transpose and apply sutra. Let's continue here. If you look carefully, you will find conventional method and A, which is A, and transpose and apply method, which is C, are very similar and in fact are equivalent. It would seem like that for nickel method and transpose of and apply method, insight came from algebra. It looks like that it might have come from algebra. We have two methods of division, which is the nickel method and transpose and apply, which are similar based on same concept, and it seems like insight for these methods might have come from algebra. Let's continue. So that means algebra is a precursor to our these two methods of division, nickel method and transpose and apply method of division. Let's continue. From here on, we'll use not use conventional method because they are two are equivalent, and we'll use the transpose and apply sutra here. Okay, so let's divide by another example of dividing by x minus 1. And this time my dividend is 3 times x to the 5th power plus 4 times x to the 4th power minus 2x cubed plus 7x squared plus 1x minus 7. And we are dividing by E2 is x minus 1. Let's continue. So this is my equation here, expression here. Dividend is 3x to the 5th power 4 plus 4 to the x to the 4th power minus 2x cubed plus 7x squared plus 1x minus 7. Let's continue here. Okay, and we're dividing by x minus 1 is like dividing by 9. Remember we said that when we were comparing an expression algebra to a number in decimal number system, the two were equivalent if x were 10. So x is like a 10. X minus 1 is like a 9. So it's just like dividing by 9. We would apply same thing. We need to keep adding dividend digits. Okay? That's what we did before. Okay? Great news. When we're dividing dividend digit, doing division by 9, sometimes we'll get too large a value for either for the quotient or for the adjustments. For quotient value was sometimes too large. Okay, now you don't have to worry about that. Multiple digits, there's no carry and no borrows in algebra. So at least in that sense, you don't have to worry about multiple digits. If there are, that's fine. Okay, we'll keep them. Okay, let's continue. Now divide by x, that's like dividing by 10. Okay, let's continue. So when you divide by x, first of all, we just did, if I divide this term by x, I get one fewer flag value on left side and minus 7 on the right side. Okay, so we just did. So when we divide x fifth by x, I get x to the 4th power. When I divide x 4th by x, I get x cubed. When I divide x 3 cubed by x, I get x squared. When I divide x squared by x, I get x. When I divide x by x, I get a constant term. Okay, and the remainder is a constant term here. Let's continue. But now we divide first column here, which is plus 3. Okay. we're going to divide first column here by 1 and add that to next column. Let's continue here. So we get 3 here, and 3 plus 4, we're going to add 3 to next column here, would give me 3 plus 4 is 7. Let's continue. So we get 7 here. Okay, then I would add the 7 to the next column here, would give me 5 here, plus 5. 7 minus 2 is plus 5. Now would add this plus 5 to next column, plus 7, 12 here. And I got 2 digits, not a problem. We'll keep the 2 digits. Okay, we got plus 12 here. Now plus 12 we add to the next column here. That gave me plus 13 here. Then this plus 13 add to the next column in the remainder section here, and no more division. Okay, so get plus 6 in the remainder section. So answer is 3 times x to the 4th power plus 7x cubed plus 5x squared plus 12x plus 13, and remainder is 6. Continue. That gives me E1 divided by E2 is 3 times x to the 4th power plus 7x cubed plus 5x squared plus 12x plus 13. Remainder is 6. Let's continue. Now we'll use the x plus 1 like division by 11. Okay, let's continue here. That's like transpose and apply, but let's see what happens. Yeah, division by 11 is like transpose and apply method, and division by 9 is like Nicolet method. Okay, let's continue here. So we just got to rearrange the terms. This is my dividend here. Okay, I just said x fifth column, x fourth column, x cubed column, x squared column, x constant x column, and a constant columns, and these are my coefficients of those flag values. Okay, let's continue. First thing we'll do is again it's a base number is x, surplus is plus 1, and transpose is minus 1. Okay, we'll divide by x plus 1 like dividing by 11. So we need to keep subtracting quotient digits from the next position. Let's continue here. Great news, no problem with multiple or negative digits values. Okay, so if the negative digit values come in, that's fine. We'll keep them. Okay, no adjustments for those. Divided by x is just like dividing by 10. And let's see how we do that. So we just did part of that. So when I divide x5 by x, I got x fourth. When I divide x fourth power by x, I get x cubed. When I divide x cubed power by x, I got x squared. When I divide x squared power by x, I got x. When I divide x by x, I got a constant term, and the remainder is a constant term. Let's continue here. And now we divide the first column by 1. So when we divide plus 3 by 1, I got plus 3. Now I have to subtract that quotient from the next position value. Okay, so I got minus 3 here. In next column I have minus 3, and I would divide that by plus 1 okay? And next column, dividing next column and adjust, so I got a minus 3. Then we would add plus 3 here, and the next is dividing next column here by 1. I get plus 1 in the column, and then adjustment for the. Okay, let's continue to divide again here. Now we're going to divide by x plus 1, and we'll continue the example here. So far we have gotten so far. Plus 1 was the quotient here, and minus 1 was the adjustment. Okay, let's continue here. Now we'll divide in next column and adjust. Okay, so next column is minus 1, and adjustment is plus 1. Okay, now we'll divide in next column. 7 plus 1 is 8. Divided by 1, which is quotient is 8 here, and adjustment is minus 8. Okay, and that means I got in what I got here so far. So I got E1 divided by E2 is 3x fourth, 3 to, and x is 4th power, minus 3x cubed plus 1x squared minus x, and plus 8, remainder 0. Let's continue. Let's do a general example for division. E1 is 3 times x to the 5th power minus 3x squared plus 2x minus 3, and E1 2 is x squared minus 3x plus 1. Let's continue here. So base is x squared right here, which is my divisor. Surplus is, after subtract x squared from here, surplus is minus 3x plus 1, and transpose of that is, which is negative, is 3x minus 1. Let's continue. Two-step division is first we divide by x squared and then by 1. Let's continue. So this is the way I set up my problem here. This is my dividend part, and these are my x with the flag values, and these are my coefficients here. Okay? See the two zeros here? If you do your division in any other way, you'll be better off if you fill in the ranks with the coefficients of 0. Okay? When I did like the way I do that, make up the columns here, and then these two zeros came in right away because I got a fifth power here, second squared here, and x here, and constant term here, and these two were not filled in. I filled in with zeros. Okay, let's continue. This is my divisor, which is x squared minus 3x plus 1, and this is my transpose. This is the transpose is just right here, 3x minus 1, which is I'm going to use 3 and a minus 1, 3 and a minus 1. 3 in one column and minus 1 in the next column. Let's continue here. We first divided by x squared, our first division right here. We just did. Okay, we divide by x squared. Anything, any of the dividend positions with a flag value of less than 2 are in the remainder column, and the ones more than are equal to 2 are in the quotient column after we divide by x squared, and the flag value is reduced by 2. X squared has a flag value of 2. I divide x5 by x squared, I got x cubed. When I divide x to the fourth power by x squared, I got x squared. When I divide x cubed by x squared, I got x. When I divide x squared by x, I got a constant term. Let's continue here. Now we'll divide first, in first column we'll divide by 1, or second division. Okay, we just got 3 divided by 1 is plus 3, and now we have to make adjustment, which is 3 times 3, 9 in next column, and 3 times minus 1 is minus 3 in the one column after that. Let's continue. So we get first adjustment here. This is my next adjustment here. Continue. In second column we divide by 1 again and adjust. So we get 9 here. Plus 9 divided by 1, our second division, 9. Okay. Adjustment is 9 times 3, 27 in this column, and 9 times minus 1, which is minus 9, is in this column. Let's continue here. So plus 27, 9 times 3, and minus 9, 9 times minus 1. Let's continue. Now we divide the next column here, which is minus 3 plus 27. We divide by 1, our second division. So we got plus 24 here. So now make adjustment for that. 24 times 3 is 72. Adjustment here, and 24 times negative 1 is minus 24 here. Okay, let's continue here. Okay, so we got an A plus 72. Okay, and okay, now we have divided this column here. Okay, okay, divide fourth column and adjust by 1, which is 72 minus 12 is 60. Okay, plus 60. Adjustment is plus 180 and minus 60. Let's continue. So E1 divided by E2 is 3x cubed plus 9x squared plus 24x plus 60. Remainder is in this column 158, 180 plus 2, 182 minus 24 is 158, and here minus 63. Okay. Let's do another example for practice here. Let's continue. E1 is example is 3x cubed minus 5x squared plus 2x minus 6, and E2 is 3x plus 1. Let's continue here. So base is 3 times x. This is my base here, and surplus is 1, and transpose is minus 1. So it's a 3x plus 1. So surplus is from surplus of divisor from the chosen base is plus 1, and transpose of that surplus is minus 1. Let's continue here. We'll set up step division. First we will divide by x and then by 3. Okay, let's continue. This is the way set of the problem here. Okay. 3x cubed minus 5x squared plus 2x minus 6, and it's 3x plus 1. My divisor and transpose is minus 1. Let's continue here. So first we divide by x, or first division. This is my first. Let's divide that by x. So we did. So x cubed by x is x squared. X squared divided by x is x, and x divided by x is a constant term, and remainder is a minus 6x constant term. Let's continue here. First we divide in the first column by 3, which is my second division. So 3 divided by 3 is a plus 1. Now we adjust plus 1 times the transpose minus 1 in the next column. So in next column we'll divide minus 5 and minus 1 add up to minus 6. Okay. So in next column we divide by 3 and adjust for transpose again. So we did it. Minus 2 is my quotient in the next column. So I got minus 2x, and adjustment for that is minus 2 times minus 1 is plus 2. In next column I have adjustment of plus 2. Let's continue here. Great. So let's continue. Now we are going to divide by 3 here. 2 plus 2 is 4. 4 divided by 3 is 4 third. There's no remainder here. When we were doing a division in the number math, there were remainders involved. Here there are no remainders, but we do have to live with the coefficient with the fraction in it. Okay. So we got a fractional coefficient here, 4 third, and this is improper fraction, and I hold on to that. If you care to, you can change that to a mixed fraction. Okay, continue. And now adjustment for that is 4 third times minus 1. It is negative 4 third. Let's continue. Now we add up in the remainder column. I have a negative 22 divided by 3. Again, it's an improper fraction, and if you care to, you can change that to mixed fraction. Let's continue. So use the fractional value. There's no remainder and no carry. We got a fractional value here. There's no remainder and no carry. We use the fractional value. Let's continue here. So that means that e1 divided by e2 is x squared minus 2x plus 4 third. Remainder is minus 20. Here we determine e1 divided by e2, where e1 is 5x squared plus x plus 4, and e2 is x plus 1. Let's continue. e1 is 4x squared minus 5x plus 4, and e2 is x minus 1. e cube is 3x cubed plus e1 is 3x cubed plus 2x squared minus 4, x plus 5, and e2 is x squared plus 3. e1 is 2x cubed plus 2x squared minus 3x plus 4, and e2 is x squared plus 2x plus 3. e1 is 3x cubed plus 5x squared minus 5x plus 2, and e2 is x squared plus 0x minus 3. Let's continue. And some more examples here. Okay, let's continue.